Synth 1 is a full-fledged synthesizer that's integrated into Wwise. When it's connected to a MIDI-based music track, you can take advantage of creating a lot of sonic diversity in your music with minimal impact on memory or space taken on disk. To experiment with the capability of Synth 1, we'll use this Boss A section of music composed for the game's Big Boss Fight. Let's take a listen. These MIDI tracks are already set to target these sound SFX objects configured with Synth 1. To understand how that was done, be sure to watch the video in this series that explains that process. Now let's listen to the arpeggio track on its own. As we work, we'll need to repeatedly play the Boss A music segment in order to hear how our adjustments sound in context. So we'll pin it in the transport. We'll start by modifying the sound of the arpeggio synth line. Let's take a quick listen to it by itself. To adjust the sound, we'll need to look at the arpeggio synth sound SFX object that is configured with the Synth 1 plugin. Select the arpeggio synth sound SFX object, and then in the contents editor, double-click the plugin icon to open the source editor. The foundation of a synthesizer's sound is built with its oscillators, each providing a type of sound based on a type of waveform. In Synth 1, you have two primary oscillators, plus a third one dedicated to creating noise. The default waveform for oscillator 1 and 2 is a sine wave. By changing the waveform assignment, you change the core sound. Let's change the waveform property of oscillator 1 and oscillator 2 to sawtooth. Then let's take a listen. Changing the waveform type may also change the perceived volume. The synth is a bit loud, but we can adjust the volume of each oscillator. Individual control also allows us to change the balance of volume between the two oscillators, creating different combination tones. Change the level of oscillator 1 to -15 dB and oscillator 2 to -12. To thicken the sound a bit, we can detune each oscillator's pitch. The values are expressed in cents. A small adjustment can go a long way in broadening the sound. Let's change oscillator 1 to -6 and set oscillator 2 to +6, and let's see what happens. Now we can hear that the sound feels much wider. Synth 1 even provides an FM frequency modulation feature that allows the sound of oscillator 2 to interact with the development of oscillator 1's tone, providing even more sonic options. We'll change the FM value to 75. Now we're beginning to achieve the 8-bit type of sound from classic video games. A major difference in working with MIDI tracks is that there is no given volume that they will play at. Remember that the volume of the track is completely derived from the sound that the MIDI track is assigned to, making it impossible for the composer to deliver a MIDI file that can predictably blend with the other audio tracks being provided. This means that extra care has to be taken in setting the overall volume level of a source plugin. The sound may be a bit loud compared to the rest of the music, so you can adjust the volume down a little using the level property. Adjusting the level property does not affect the relative balance we've already established between the oscillators. While many of the properties found in the Synth 1 source editor will be familiar to anyone that's used a synthesizer, something that's missing are envelope settings. Envelope settings would control how the sound fades in or out for each note played. With Synth 1, using an envelope with the sound is possible, but the approach to do this follows the model of how share set modulators can be used to control properties found throughout Wwise via RTPCs. In fact, you may have noticed that the RTPC icon for the output level property is orange. This is because an envelope RTPC is attached to the output level property in Synth 1 by default. We can access this functionality by clicking the RTPC tab in the source editor. Here we see an RTPC curve that indicates the output level is controlled by the modulator envelope. It's extremely important to understand that this is not a visual representation of the envelope being applied to the sound. It instead represents the range of intensity the envelope has on the sound. In this example, The envelope will start the attack at -120 dB and will have a maximum sustained level of 0 dB. We can see the actual envelope values on the right side of the editor. Here we can see settings common to envelopes used in synthesizers, like attack, sustain, and release. To create a more staccato feel, we'll shorten the release time to a value of 0.05. And let's listen. Now the notes are more pronounced when played, making it easier for each note to be heard in the mix. Low-frequency oscillators, also known as LFOs, are another common feature found in most synthesizers. Don't misunderstand the name as having something to do with low-frequency sound generation. An LFO, instead, is a way to modify property settings by changing its value over and over again in a defined pattern that repeats at a specific rate. We'll explore the use of an LFO in conjunction with the Boss A melody track. Let's close the source editor and we'll take a listen. This track is targeting a different sound SFX object that also has a Synth 1 set as a source. We'll use an LFO to create a vibrato sound that can be heard on these longer notes. Vibrato is a repeating, rapid rise and fall of the sound's pitch, so LFOs work well to create this effect. With the Melody Synth Sound SFX object selected, we'll click on its Synth 1 plugin so we can see its source editor. Here, we see the RTPC tab already selected. We see the default envelope assignment like we saw earlier in this video, but we don't see anything related to an LFO. In this same area, we can add an LFO. Click the selector on the second line, and the first step is to choose what property we want to modify. In this case, that should be Oscillator 1, Oscillator 1's transpose property. Now we need to assign an LFO to control that property. Click the selector under the X-axis column and choose LFO. And we're going to create a new LFO. We'll name it Synth LFO Vibrato. This creates a modulator share set that could be reapplied to other synthesizers. Just as you learned with envelopes, the RTPC curve does not represent the LFO itself, but instead represents the amount of intensity the LFO will have on the selected property. Currently, we're seeing both the envelope and the LFO displayed in the RTPC graph. To display the scale for the LFO, click its line in the editor. Now we can see that the vertical axis represents a change in pitch expressed as cents. So currently, there would be no pitch change, regardless of any changes you make to the LFO properties. To change this, we'll need to adjust the point on the right side. But for a vibrato effect, we don't want the pitch to change too much. We'll zoom in on the vertical axis. And set the maximum amount of pitch change to 150 cents in the Y-axis property. We can type in specific values in the Y property value. Now, let's look at the properties for the LFO itself. We see a depth value, which displays a default value of 100. Think of that as a percentage, indicating the depth or intensity we'll reach as it relates to the 150 cents in pitch change you defined earlier. The speed of the vibrato will be determined by the frequency of the LFO. The value for the property is expressed in hertz, or cycles per second. We'll set this to 6. Now, when we play the music track, we should hear the vibrato effect on the melody line. While the vibrato effect is working, it feels like it's a bit much to have it occur all the time. When a musician plays a keyboard, they will often use a physical control called a modulation wheel to modify the sound when desired. The movement of the modulation wheel is communicated with a special type of MIDI message called a continuous control number. There are many different control numbers in the MIDI protocol, but the one generally used in conjunction with a modulation wheel is continuous control number 1. When the synth lead MIDI track was recorded, the keyboard player turned up the modulation wheel during the longer notes at the end of the phrases, presumably to create a vibrato, but only for those longer notes. To create the intended effect, we can use the control number 1 data that's present in the MIDI track to modify the LFO's range property in real time. To the left of the depth property value, there is an RTPC symbol. Because it's gray, this means that this property is not being controlled by an RTPC. Double-click it, and the modulator editor will appear with the RTPC tab already selected. First, we'll click the Selector button and choose what target we want to affect, which in this case is the depth property. For the x-axis, choose MIDI, CC 0 through 31, CC number 1 modulation. An RTPC graph appears. Every continuous control message has a value assigned that ranges from 0 through 127. This is represented at the bottom of the RTPC graph. The default curve indicates that regardless of the modulation value, the LFO depth will always be at 100%. We need to change this so that if the modulation value is low, the value of the depth property will be as well. Drag the left control point all the way down to a value of 0. We can further modify the response so that the modulation value must be fairly high before the vibrato is noticeable. Right-click anywhere on the curve and choose Exponential Bass 3. Now let's take a listen. We hear the vibrato, but only on the longer notes. Now let's listen to all of the tracks for the Boss A music. Now, with your understanding of Synth 1, you can easily go back and adjust the sounds of your synth tracks to your liking.